So welcome to the second of the 4 videos. This one is about money. So if you like money, you'll want to play along. If you like your grade, you'll also want to play along. Okay, so it's not about personal wealth, it's about corporate wealth, but it might be your corporation one day. Each year a company earns 15% of its own net worth, okay? And additionally, it pays $300 million per year in payroll. We're going to assume a continuous rate, although my own personal reflections are I don't get paid continuously. And so we're going to let W of T be the net worth in millions of dollars, just measure everything in millions of dollars. And so the first thing you want to do is you want to find an initial value problem that describes this phenomenon. Okay, so if you want a hint, if you don't, press pause now, but if you want a hint, think about this. What is causing W to change? And so if you can figure out on a high level what's causing W to change, and then formulas to represent that, then the differential equation writes itself, although you should really write it too. So the next time, hit pause now, and the next time you'll see the differential equation. And true to my word, here's the solution. You'll notice I made an initial value problem somewhat by saying W of 0 equals W0. That's saying that there is an initial value, but of course, we don't know what it is at this point. We're going to want to look at kind of the family of solutions. So the differential equation itself, wealth is changing for 2 reasons, or worth, I should say, is changing for 2 reasons. You're gaining 15% per year with the wealth you already have. It takes money to make money, and so you get the change is increased, like W is increased 15% because of that. But in addition, there's this 300 that is taken off per year no matter what, and that's the minus 300. So you have 2 things causing W to change, the fact that the worth goes up and then minus the payroll, the 300. So I hope that makes sense, and I hope it coincides with what you had. So the next step is to solve the differential equation. I will wait here while you do that. If you're having a little bit of trouble, you will see a hint next before you see the solution, but I encourage you to try to blast through without the hint. Many colleges nowadays are offering content like this online, but very few use the technical terms such as blast through. But anyway, if you need a hint, I'm anticipating you might have trouble integrating originally. I mean, you can separate the variables, but then the integrand on the left is dw over 0.15 w minus 300, and you can do that. It's a w substitution, and you'll get your answer. What makes things slightly easier is what I've done here. I pulled out the 0.15, and I'm going to keep it on the right hand side and bring the other thing under. So dw over the w minus 2000, it's just a slightly simpler integral. You can still think of it as a tiny w substitution, but the d tiny w isn't anything more than just d capital W. So why don't you give that a whirl and see how you do. And so the next screen that you'll see will have the solution to the differential equation and to the initial value problem where you plug in W naught for W0. Okay, I'm just showing you the bottom of this screen because only so much can fit in this little video that I'm doing. So I did this with the hint that I used. If you don't use the hint, then you should get the same answer. But notice when I got to doing the integral, I integrated dw over w minus 2000 to, it turns out to be exactly natural log of w, absolute value of w minus 2000. And then I solved for c, sort of, I got it in terms of w sub 0. Okay. Now what I want you to do with this solution, besides applaud because presumably you got it correct too, is to think about what the solution curves look like and how it depends on W naught. And so the next screen is going to show some of the solution curves, and we'll talk about their significance. I will talk about it. You're free to talk along with me, but you know what I mean. Okay, and so you get a family of exponential curves, some opening up, some opening down, and they depend on the initial value W naught. Notice, and if you looked at the original differential equation, which I didn't put on here because I'm a bad professor, 2000 is an equilibrium solution. dw dt is 0 when W is 2000. And so if you had 2,000 million, also known as $2 billion in your company, you would just stay at that level forever, which is most people will be pretty happy with. But notice that under this model, if W0 is greater than 2000, okay, so the y-axis, or technically the w-axis, intercept is above that line, that black line, the equilibrium solution, your wealth just increases exponentially, quite literally actually, and so it just snowballs and you make a lot of money. And it kind of makes sense because you're earning 15% of your net worth, but always giving out a fixed amount. So as long as 15% of your net worth exceeds that fixed amount, you're going to just go on forever. Sadly, if you have less than $2 billion, so if W is less than 2,000, it goes down, in which case you go broke. The nice thing about this model is it doesn't even stop at zero, so you become infinitely poor. It takes money to make money. If this was a political science class or something, I might have some commentary about that, but I'm more interested in the mathematical model, and I hope you are too. All right, well, that wraps up part 2. So I have another meaningless tag here, and so we will see you in video 3.